Did you listen to the what do you call it? The Twitter Spaces between Trump and Elon Musk?
I haven't yet.
Did you listen to? Okay, so then you didn't hear the exchange on climate change between Musk and Trump.
I did not.
Okay, Rob, can you find that? I don't know if you have it or not. Even if it's the clip, I just want to have him hear it and react to it because, you know, this was a position where Musk took the position to say, you know, climate change. He didn't fully discredit it. He came from a place of. Let me see, Rob. If you don't have it, I'm trying to get it. If it's on Trump, Musk on Twitter, I don't know where you're trying to find it. If you can see if they have it, but okay, I'll ask you until Rob finds it. What do you think? You know, the debate, because you hear scientists like, no, it's undisputed. This is for sure. This is what's happening, and here's what we need to do. Is this the one, Rob? Is this?
No, hold on one second. This is them talking about nuclear energy. Let me see if I can find.
Yeah, if you find it. But I guess the question for you would be, what does the average person not know? We're hearing what we hear about climate change. What does the average person not know that's going on?
An awful lot.
Specific to climate change.
Okay, specific to climate change. Well, I would say the biggest thing that they don't know is the degree and extent and frequency with which climate has changed naturally over and over and over again. I mean, I would say this. Okay, so explain to me how we get from half of North America. The climate of half of North America 10 to 12 to 13, 15,000 years ago was a climate like you now find at the South Pole. I mean, that's not an exaggeration. So if you believe that the climate, that there's some steady state that we're supposed to find, that's what we're supposed to, you know, we're supposed to find this whatever, you know, what are we trying to do here? Get back to the climate of the 1800s or the early 1900s? You know, people don't know the extent to which climate has changed. So I just mentioned the fact that sea levels rose 400 feet. Well, nobody's in the mainstream is really thinking about that. You know, you have to go to marine geologists. They're talking about it and realizing it. Oceanographers, paleoclimatologists who study ancient climate will tell you, yeah, it's overwhelming that evidence that the climate has changed over and over again, orders of magnitude beyond anything we've seen in the last century or two. That's what most people don't know. They don't know the degree and extent to which the climate has changed naturally without anthropogenic influences and long before we were driving SUVs and putting carbon dioxide in the atmosphere. The other thing they don't know is that the thermal capture ability, the long wave radiation coming off of the Earth that the carbon dioxide in the atmosphere can capture is limited. It's, in fact, most of the thermal capture is within the first 100 parts per million. And beyond that, it tapers off logarithmically. So that by the time you get to 420 parts per million, what it is right now, it's like a leaky sponge. A lot of the heat that's being, you understand how carbon dioxide works. It creates an envelope around the Earth in the upper atmosphere. It allows the shortwave radiation to come through that's coming from the sun, which is absorbed into the Earth, and then that is re-emitted as long-wave radiation, roughly in the about 14 to 17 micron wavelength. Okay, so it comes back from the Earth. That's what's being captured by carbon dioxide. But most of that within that window is being captured by water vapor. And there is only a limited ability of carbon dioxide to capture heat in that window, right? And imagine, Pat, that you've got a sponge sitting on the table and I take this water and I start pouring into a dry sponge. Well, you're not going to see anything leaking out until the sponge gets saturated. Once it's saturated, I keep pouring, and then what happens? It just keeps leaking out. Well, that's what's happening, is that the heat is now leaking out from the carbon dioxide. Now, we saw a spike, you know, last summer when they were saying, oh, this is the hottest month and all that on record. Well, it depends, again, on how you look at the records. I think the records are being biased by the urban heat island because most of the measuring stations are in airports, which were rural 50 years ago, 30 years ago, and now they're urban. So they're surrounded by asphalt and concrete and air conditioner condensers and everything that's putting off heat. So that's a whole nother discussion we could have about the bias that I think has found its way into the data about climate change, about warming. But the other thing that happened was this big underwater volcano that went off that disgorged enormous volumes of water vapor.
What's it called?
Hunga Tonga. Rob will find it for us. Hunga.
What an interesting name.
Yeah, Hunga Tonga. I think is what it was. Hunga.
Oh, there it is. I found it, Rob.
Yeah, there it is. Underwater volcano. Yeah, erupted. There it is, January 15th. The largest underwater explosion ever recorded by modern instruments, and had a number of effects. One of those effects is that it increased the density of the water vapor canopy, which captured heat. And I think that's what really made that summer exceptionally warm of 2023. In fact, that water vapor is still clearing out. So there's a lot of those things that people just don't know. And you have to follow the whole controversy to know that kind of stuff.
Rob, can you find a clip of the Hunga Tonga on maybe one of the greatest names for a volcano? Can you find a clip of what this Hunga Tonga did? I found one, but I want to see if you got one here and the effects of it.
Well, let me put it to you this way. The climate change establishment is trying to downplay the effects of it. But there is independent research that pretty much confirms that, yes, that enormous injection of water vapor would have had...
Play that, Rob, on 2.0. If you can play that clip on 2.0 speed. So why are they trying to downplay it, and why do you think it's a bigger deal than what the establishment climate change folks are telling us?
Well, because, again, it points to the idea that the climate changes naturally without help from humans. And the whole climate change narrative is about... I think it's about ultimately using climate change towards social control.
This is what. By the way, Rob, do you remember this at all?
I don't.
I mean, we cover a lot of different issues. I don't ever remember this being a mainstream, like a big story. That's what happened. That's a pretty big deal for something like that to
Absolutely.
take place.
And I think it was deliberately downplayed. I think it was deliberately ignored. Because, again, I think the strategy now is to focus exclusively on anthropogenic-driven climate change.
Okay, so fear has got a big influence over, what does that say, is a volcanic island located about 30 kilometers southeast of Faunu Island in Tonga. Click on it. Is it trying to show us something? Let's just see what happens with the sun.
Well, it's near that island. I think that should be right on there on that.
The volcano itself is a submarine volcano that breached sea level in 2009 due to a volcanic eruption. That's the Hunga Tonga Island right there to the top right.
Yep.
It lies underwater between two islands, Hunga Tonga and Hunga Ha'apai. Who comes up with these names? The ongoing eruption is about 7 times more powerful than a volcano's last outburst. Huh. Interesting. Okay, so this event here. Just 2 months ago, a meteor, what was it, 400 to 800 feet,
yeah,
the size of Eiffel Tower, I believe, that was in between Earth and Moon.
And the Moon.
And no one really, that was also a non-story, right? So
I knew about it.
Okay, tell us about it.
I even wrote about it. Well, it was slightly different trajectory. It impacted the Earth. It would have detonated with an explosive force of about 600 megatons. Now, what's 600 megatons? Well, the biggest hydrogen bomb tested in the U.S. arsenal, I believe it was Mike, in, Rob will look this up for us, maybe 1951, largest U.S. hydrogen bomb test. And it was about 15 megatons. And that's about 1,000 times greater than the bomb that was dropped on Hiroshima. And in fact, I think I included a slide, couple of slides.
1,000 times more?
Yes.
Than what was dropped in Hiroshima?
Yes.
And that's what this meteor just 2 months ago was capable of doing?
No, much bigger than that. I said that, okay, good. That's in my slideshow right there. Okay, so Okay, look at the bottom, 15 kilotons. That's Hiroshima.
Okay.
15,000 kilotons. That's 15 million megatons of TNT. That's the size of the largest hydrogen bomb tested by the United States. 15,000 kilotons. That's the largest hydrogen bomb tested by the U.S.
Yep.
Now, the Soviet Union in 1961, I believe it was, tested the Tsar Bomba, which was 50 megatons. So it was what, 3 1/3 times bigger than this. Okay, so the impact of that object, that asteroid that passed between Earth and Moon, would have been about 600 megatons. Now, the average size of the bombs during the peak of the Cold War on the U.S. arsenal was less than a megaton. So if you could imagine 600 megatons, that's 600 hydrogen bombs going off if that thing had hit the Earth.
What would have been the consequences if it would have hit the Earth?
Well, you would have had a fireball about 3 miles wide going up. You would have had about a 6.7 to 7.0 earthquake. You would have had winds near the fireball of up to 8,000 miles per hour moving outward. You would have had a shock wave that would have blown your eardrums out 20, 30 miles away. Probably if it was a populated center like East Coast or West Coast, you'd had 1 million people vaporized, and you'd probably had another 2 or 3 million die from secondary effects. It would have been hell. And it would have had global consequences. It would have affected global climate probably to the point where it could have disrupted agriculture for 3 to 5 years until all the dust and soot from the fires, the secondary fires, because that impact is going to blow stuff up in the air, right? And that debris is going to fall back to Earth, and it's going to create a whole bunch of secondary fires.
So why did the media not really cover it much? And it's just kind of like, yeah, it happened, and there wasn't too much of a worry and concern about it.
Again, I think it's because it doesn't fit the contrived narrative.
Why doesn't, though? Why wouldn't it fit the
To me, it would. And to me, it should deserve a much, much higher priority. I collect this stuff since the late 80s. I've been collecting information on near misses. There we go.
NASA plans for a doomsday scenario of asteroid with 72% chance of hitting Earth in 14 years. And by the way, that's 4 days before the asteroid, right? June 29th is when they, if I'm not mistaken, Rob, June 29th, 2024, they discovered it 13 days before, not sooner. They only discovered it 13 days before.
Yes.
Named 2024 MK, passed within 180,000 miles of Earth's surface, 75% the distance between Earth and the Moon, size of Eiffel Tower, came between Earth and the Moon. So 180,000 miles, just for context. Is that a big deal? Or is that not, like, it was almost a missed?
That is, in astronomical sense, that's like a whisker. And see, here's the thing. If it comes that close, see that, you got a picture. These things are out there orbiting the sun, right? A lot of them are, think of it like a cosmic ping pong game. And a lot of these things like comets and asteroids that are circling in an orbit that takes them out to Jupiter and back to the sun again. Well, do you remember 1994, summer of 1994, July, when 21 objects of a fragmented comet plunged into Jupiter? Rob, Shoemaker, Levy, Levy 9. Shoemaker, Levy 9. And pull up some images. There we go. Okay, so this happened. Yes, this was an incredible. This was at the time the most watched astronomical event in history. If you go down there to the lower right, you're going to see. Okay, click on that, open it, and you'll see that that is what is called the chain of pearls. Now, here's what happened. This thing is out there. Picture. It's circling, going into the sun, going back out, going behind Jupiter and coming back in. It's a big elliptical orbit. Each time it's going out there to Jupiter, Jupiter's gravity is pulling it in closer and closer. Okay, the last time before it was discovered, it has just passed within Jupiter's gravity field. Jupiter's gravity field is so powerful that it literally ripped a single comet nucleus into 21 pieces. And that's what you're seeing here, the so-called string of pearls. Now, astronomers can predict orbits if they know what are called the orbital elements. And so it took 3 months of observations, and you've got enough of the ellipse, the orbital ellipse, to reconstruct the whole ellipse. You've also got data on the velocity. So when you put that together into your models with the other orbital elements, you can now make predictions. And so after they discovered this thing just after it's coming around behind Jupiter and in the early stages of breaking apart. So as it moved around the sun, all of this stuff gets strung out, like they called it the string of pearls in space, comes back around, and after 3 months of observations, they projected it forward to where it was going to cross Jupiter's orbit again, and then realized that where it was going to cross Jupiter's orbit, Jupiter was going to be right in that spot. And so they were able to predict that in the second week of July, 1994, these 21 pieces were going to fall into Jupiter. Now, one of the things, and I think I probably put some of this in my slideshow, is that we're discovering that, yes, okay, Rob, go back up, go back to the diagram there of the comet nucleus, come down, right, stop. Go up to where you've got the drawings. You're right there, go to that one. No, now you're going to, well, that's, he's going to play, there we go. Okay, so this is now the model of a comet nucleus. And it's basically an icy matrix. And within that icy matrix, you've got all of these chunks and pieces. When that matrix fragments, you now get all kinds of sub-nuclei or yeah, so you got a Halley-type comet nucleus. So what happened? You had a single object like this that got ripped into 21 pieces. Now, if it hadn't plunged into Jupiter, each one of those 21 pieces could have spawned a whole nother generation of cometary debris. Now, do you know, are you familiar with the explosion in Siberia of 1908?
Yes.
Okay.
Yes, it's called the Tunguska event.
Tunguska event, yes. The Tunguska event of 1908 was probably a piece of a comet. It was about 150 feet in diameter, and it had, what's interesting about that is the explosion, the energy of explosion of that Tunguska event was about 15 megatons. That's the estimate. So conveniently, we've got a natural event that was about 15 megatons, but we know the destructive potential of a 15 megaton explosion because we tested bombs with that level of energy released. So I don't know the area, the area here, but if you look at Atlanta, you know 285 that goes around Atlanta? Okay. If you look at the area inside of Atlanta, inside of 285, the urban area, it's about 800 square miles. That is about the same area that you see in that picture right there of total devastation. So in other words, a Tunguska explosion, 150-foot wide meteor or piece of comet coming in. Now, important distinction here. Tunguska was an atmospheric explosion rather than a direct impact.
What does that mean?
Well, it means that it never reached the surface of the Earth. It didn't hit the Earth and explode a big hole in the ground. It exploded in the atmosphere.
Got it. It was going some 40,000 kilometers an hour. I have some of the details that I wrote down here. Asteroid the size of a White House. It destroyed 2,000 square kilometers.
Yep, about 800 miles.
And then they said this happens every 500 years. By the time it hit our atmosphere, it was going 40,000 kilometers per hour, exploded like a hydrogen bomb.
Yeah, like a 15 megaton hydrogen bomb. And it had that exploded, like if you had, and first of all, the number 500, I could show if maybe I'll come back at some point, we can dive into some of these questions deeper. I think that that's wrong. I think that we have to look at once or twice a century. I think that's I don't know.
You think it's once or twice a century?
At least.
Okay.
At least. Yes.
And Rob, there's a clip because and this hit Russia, right? And there's a
Siberia.
Siberia. And there's an opening, trying to see which clip to show that shows what it looks like now. There's an image if you can pull up. I wish I could find it to show it to you, Rob. Yeah, there's a video that actually shows what it would look like if it were to hit. I don't know if you have it or not. Let Let me see if I got this here. So for you, you're saying it's not 500 years. You're saying it's more likely to happen more often. Now, let me ask you this: when you're talking about Jupiter, right? Mm-hmm. And you say the gravity field.
Yes.
Is there? That's the one right there, Rob. That's the one right there. That look right there.
So that's called the Great Swamp. Like that's right under the epicenter, and the area of devastation where the trees were blown down is way bigger than what we're seeing right there. But the forest is growing back very quickly. I mean, here it's well over a century now, and the forest is regrowing. Yeah. The Great Swamp
is Earth. Does the gravity field, Randall, of Earth set up in a way? Because if there's so many meteors that going by, how come we don't get hit by it more often? Why don't we have more that are hitting us? Is it built in a way to protect it from happening?
If you remember,
I know I'm asking an innocent question, but I'm not in the world. That's why I'm wondering what the answer.
Well, first of all, I think that the evidence that I've been looking at for years would suggest to me that the impact rate is not uniform through time, but there are periods where it's more concentrated, if you want to say more bunched. And then you'll have a period where it's relatively calm, and then you'll have another period where there'll be an increase in meteorite or cometary impacts. Now, there's so much, I mean, we're kind of like in a new frontier here of understanding the cosmos of which we're a part. The first asteroid wasn't even discovered till January 1st, 1801. That was Ceres. And then it was a very slow discovery. And then in the last 20 or 30 years, it has really accelerated. I believe at the end of my slideshow, Rob, I think I have a video that was put out by NASA. Let's see here. If you can pull over and you can enlarge the thumbnails over, there we go. This is a video released by Russia, declassified. Go down. We're not going to get any volume. Go down and hit play. Back out of there. Unselect and go back to the same slide. We'll get Rob here trained well for the next. Okay, so now go down to the lower right toolbar.
Same one you press, Rob. All the way at the bottom.
All the way at the bottom.
All the way at the bottom, Rob, right there. Right there.
There. And turn the volume up. And now, yeah, there we go. Now, there we go. This is 50 megaton explosion.
Russia put this together.
Yeah. So the impact of the object we were just talking about that passed the Earth on June 29th, that would have been 12 times more powerful than what we just saw. And that's 50 million megatons of TNT, the largest hydrogen bomb ever tested by the human race is what that video was. 10 to 12 times more powerful than that would have been that object from June 29th.
In these uncertain times, if there's anything we need people to believe the future looks bright. So if you've heard about me saying this mission to you, we're on a mission to get 1 million people to wear this gear, and this is what we're doing. If you buy one of these hats, there's a category of buying one hat, getting the second one free. If you haven't yet worn this gear publicly, go ahead and test it out. Buy some of the gear, wear it in public, and see how many people will stop by and say, you also watch Valuetainment? You also follow PBD Podcast? I do too. Place your order. Go to vtmerch.com, click on the link above or below, place your order, and represent the VT and the PBD Podcast gear.
So if you like this clip and you want to watch another one, click right here. And if you want to watch the entire podcast, click right here.